In this video, we're looking at how we define the parameters that surround a mathematical relation. So rather than just notating the interval that it exists in or particular excluded values, we're just sort of talking about it in a more general term, and this is often the way it's applied to graphs and functions and that sort of thing. And it's referred to as the domain and the range. It's going to allow us to be more specific when we're graphing something if we have particular values that we need our graph to exist between. So we want to be able to define a relation and identify the domain and range both from an equation and from a graph. So remember that when we list a coordinate, we end up with an ordered pair. So we usually put that as x, comma, y in our round brackets. That's just a pair of elements, x and y, but we usually use it to denote a location on a Cartesian plane. A relation is going to be a set of ordered pairs. So rather than just one ordered pair of x and y, we're going to have x1, y1, x2, y2, x3, y3, and so on. So these two examples here, relation S and relation T, are sets of ordered pairs. So we've got this, the set S is going to be 1, 1, 1, 2, 3, 4, and 5, 6, whereas T is -3, 5, 4, 12, 5, 12, 7, -6. Every relation, so every set of ordered pairs, gives us two more sets. These are called the domain and the range. The domain is going to be effectively all of the x coordinates, and the range is going to be all the y coordinates. So the domain is the first number of each pair, the range is the second number of each pair. So for example, in those examples, the domain of S is going to be equal to the set 1, 1, 3, 5. But we don't need that second 1 in there, okay? Because we only need to list elements of a set once. And the range of S is going to be the set 1, 2, 4, 6. Because that's the second numbers in each of those. Sometimes we're going to have a rule relating the elements in the domain to the corresponding elements in their range. Okay, you would usually have seen this in the form of some kind of an equation. So it's usually y equals, say, 2x plus 7, right? That would give you a straight line, but that's a rule. So that's defining a type of relation. So if we look at this set here, we can see that this is the set of x and y, so the pair of x and y, such that, remember that's what our colon means, y equals x plus 1, where x is an element of 1, 2, 3, or 4. Okay, so x is either 1, 2, 3, or 4. What this gives us is the set of ordered pairs. So remember, we've defined our set here of 1, 2, because if x is 1 and y is x plus 1, then 1 plus 1 is 2. If x is 2, y is going to be 1 more than that. So when x is 2, y is 3. When x is 3, y will be 4. And when x is 4, y will be 5. And then we close our set. Okay, the domain of this is going to be the set 1, 2, 3, 4. So our x values. And the range is going to be the set of our y values, 2, 3, 4, 5. Now, obviously, we don't always want to just list these sets. We can represent those relations as a graph. So this one that we've just had, the y equals x plus 1, we can represent that as a graph. So let's say we've got, make this 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. We're going to plot those points that we just decided were in this relation onto this graph, because they're going to form discrete points, okay? Because we just listed a set of coordinates. So when x was 1, this is our x, this is our y. When x was 1, y was going to be 2. So we put a point there. When x was 2, y is 3. When it's 3, x is 3, y is 4. When x is 4, y is 5. That is this relation right here, represented as a graph. If we change the domain of that relation, so if we change the set of x values to the entire set of real numbers, then there's an infinite number of points because they can take on any value that is a real number. So it doesn't just have to be 1, 2, 3. We've got 1.5, 1.4, 1.00379, right? So in order to graph that, sorry, I keep changing color and I'm not sure why. In order to graph that, we are going to have effectively just the straight line equation y equals x plus 1, right? So we would just be finding points that comes through. So this is actually going to go, I don't know how to draw this properly. It's going to go out that way as well. So just pretend that little arrow isn't there. That one there, pretend that doesn't exist. This line is going to go through -1, +1, and it's infinite because the domain of this is all of the real numbers. So it's going to go a straight line like that, goes through both points, right? And it's going to keep going in either direction. That's effectively the graph of y equals x plus 1. But we're looking at it now in terms of it being a relation with a domain that's the elements of all the real numbers. We can also use an arrow diagram to represent relations. This effectively just takes each value of x and maps it to a particular value of y. That's going to be more important in the next video where we look at functions. But so if we take this relation here, this first one of 3, 6, 3, 5, and so on, we're just taking an arrow. So we're starting at 3 and we're saying it goes to 6. The next pair, 3 goes to 5. Then we have 2 going to 5, 2 going to 4, and 1 going to 2. So we can see we've got x values going to multiple y values and multiple x values going to particular y values. This second one, 5 goes to 4 in that first pair, 4 goes to 3, 3 goes to 2, 2 goes to 1. So in that one, you can see there's only one x for each y. Set notation isn't always going to be used to describe a relation. So particularly if we have a domain that is not specific numbers, so if a domain that's element of all the real numbers or all integers or something like that, all rational numbers, then if that is the case, then it will probably be specified. But if it's all real numbers, it's just going to be written the way you've seen it before. So y equals x squared, or y equals x plus 1 when x is bigger than 0, so x is a positive number. Okay, so they mean the same thing. It's just a little bit more information in terms of writing it. And from now on, you're probably going to see it written both ways. You just need to know that the two of them are the same thing. In the next video, we're going to start going over how these apply to some other kinds of graphs, how to sketch them, that sort of thing.